Hello, I'm James Glasser, and I will be working on Project 1 for Fundamentals of Aerodynamics. This is a project on a 2D wind tunnel simulation, and you're going to be using Ansys to get this done. So starting off with Workbench, you're going to go into Geometry, and from here, you're going to make sure that your wind tunnel specifications are correct. So your height is going to be 22 inches, your length is going to be 15 inches, and you also want to make sure that you're looking at the right plane view, so Y and X, and you start from the bottom left as well. And once you get that done, you get your contraction chamber length of 24 inches, your test section length of 12 inches, and a height of 6 inches, and then your diffuser length of 42 inches and an angle of 3 degrees from the center. So for the center line, I used a construction line here. And this is how I constructed my drawing. So once you're done with that, what I do is I press pull so that it shows you your drawing. And you're going to make sure you save that, and then you'll go back into Workbench and make sure that's check marked so that it's updated. And then you're going to go into Mesh next. So in Mesh, your drawing will pull up like this. Without the mesh, it'll just be the outline. And you're going to make sure that your mesh element size is 0.007 meters, and all of these are the same. And you're also going to click on your drawing. You're going to right click mesh, insert, and then method. So for method, you're going to click automatic prime mesh and then quadrilateral shell mesh type, and then go back to mesh, right click again, insert, and then refinement. So for refinement, you're going to make sure it's at 2. And for each step, make sure you click on your mesh, your drawing. Then you're going to click generate. So once you generate, it'll show up. And next, you're going to do name selections. So this is very important for the next step. So name selections, you're going to click on edge and then click on your edge and then right click insert, and then name selection will show up right here. I've already done this, so it's not showing up. Your inlet right here. For your settling chamber, you want to click both sides, but you're going to have to control click so you get both of them. And when you do that, you'll insert name selection again. So control click for settling chamber, control click for nozzle, control click for test section, control click for diffuser, and only click for outlet. So make sure that all of these are selected. So once you're done with your name selections, make sure that everything's good, and you're going to go to the next step. So back to Workbench, refresh, update your mesh, and then you're going to go to setup. So in setup, it'll take you here, and starting from the beginning in models, you're going to go to viscous, and then you're going to make sure it's K epsilon right here. Standard wall functions, okay. And then once that's good, you're going to go to materials, make sure it's fluid, air, solid aluminum. Those will be set, so you won't have to change that really. Your boundary conditions are going to show up from your previous mesh, which is where your name selections were. So boundary conditions, you want your diffuser to be wall type, surface interior, nozzle wall type, settling chamber wall type, test section wall type. Your outlet will be pressure outlet, and then your inlet, velocity inlet. You're going to want to edit your velocity and edit your magnitude. So for this assignment, my frequency was 20 hertz. So I used this velocity test section equation, and I got 4.602 meters per second. So that's why I inserted that here, and then you're going to apply. So once you apply, make sure everything's good with your boundary conditions. Your setup's good, so then that means you can go in here, set your iterations to 200, don't go over 500, and then calculate. So everything's gonna calculate, and then you can go into contours. So that's the next step. So you got your equation, you got your drawing, now you gotta do velocity, static pressure, total pressure, dynamic pressure, contours in the wind tunnel. So your contours are gonna be in here. For contours, this is what you wanna select. Pressure, static pressure, okay? And remember, these are all from your previous boundary conditions. So once you save display, you get your static pressure showing up here in pascals, so metric. And then next, you're going to do dynamic pressure. Make sure these are your selections. Here's your dynamic pressure contour. Total pressure contour, you're selecting these. This is your total pressure contour, pascals, metric, and then velocity contour, finally. Make sure these are your selections, and it'll show you the contour for your velocity, meters per second. That's metric as well. So this program says it stays in metric. Previously, we were in US standard, so I had to do some conversions. That's all right. You also had to do conversions for the next step. So the next step is you are required to plot the variation plots. So doing the plots, velocity, static pressure, total pressure, dynamic pressure on the wind tunnel center line. So you're focusing on the wind tunnel center line for this. I went a little overboard and did everything. Didn't have to do that. You only have to do these four. Okay. So velocity center line, it'll look like this. Getting ahead of myself, you actually have to go to surfaces first. So surfaces, you got center line, and this is the dimensions I was talking about. So when you're in your drawing, the center line is 11 inches from that corner and then 93 inches far out. So that's why it was important to get your YX and start from this corner so that it's easier to plot out where your center line is going to be at. So you got 11 inches by 93 inches. So 93 is going to be 2.36, and then 11 inches is 0.2794. That's how I got that. So that gives you correct dimensions for that if you're plotting that. If you want to display it, it shows you it exists. Not showing it in the wind tunnel, but that's all right. You just know it's there. Here's your 4 plots for the assignment. So your first plot, click on that center line. Don't click right to file because you can see it in the program first. Make sure it's good. Total pressure, static pressure, and then dynamic pressure. Okay, so remember, these 4 are the only ones you're doing. To get these to Excel, you're going to press right to file, and then you're going to save it wherever. Once you get it uploaded on your computer, it'll open as a Word file. So like this, or actually it's in here. Yeah. So it's going to open like this, and you're going to have to open as a Word file. What I did was I just had the Word files and copied and pasted all the information into Excel separately, like this. So this is for 20 hertz. Now you got your velocity plot, your static pressure plot, total pressure plot, and then dynamic pressure plot. Those are all from here. And we got those from exporting from here. So these four, okay? So that completes that second part. So showing all of the solutions. Like this. So now you got all your plots, and remember we did the contours earlier, so those are completed. So that is my demonstration for 20 hertz frequency for project 1. Thank you.